Hello and welcome back to 3S Game Studio. In this video, we are gonna take a look at the combat module of the AGR plugin, which you can use for managing melee combat gameplay mechanics by helping you trace and register hits. I've set up a basic character here with a sword, and I'll show you two different types of trace and hit registration you can do. First, we have simple traces based on weapon sockets and animations. The second type isn't based on the weapon at all. It's a simple arc trace. Now let's check out the character setup and how everything works. The combat module is made of two main parts. The AGR Combat component, which manages your combat actions, telling it when to start or to stop tracing weapons, and the socket tracer component, which actually does the traces. For example, if you attack a socket tracer to your left arm weapon, it manages the traces for that arm. You can have multiple socket tracers working with the same combat component to handle different attacks or weapons. To start, you need to register a tracer component with the combat component using an ID. This ID helps the combat component know which tracer to use during attacks. I'm using different components for different attacks here. The animations themselves have animation states you can right-click and configure to decide when the trace should happen, specifying the frame range for tracing. In the animation notify, you tell it which tracer component ID to use to start tracing. You might wonder why there is this complex setup with multiple tracers instead of just one. Some games have complicated hit detections, for example Souls-like games, where not only the weapon but also the body parts register hits. Each body part needs its own socket tracer, starting and stopping at specific animation points. For example, after a sword attack, you might do a kick, so you need a different tracer for legs or separate tracers for left and right punches. Configuring this is simple. Select your combat component and set the segment count, which is how many traces happen between the sockets on your weapon to fill gaps. For example, my sword has 3 sockets, so it uses 3 segments to cover the area. If you increase this number, you get more smaller boxes tracing the sword, giving more precise detection. You can also override trace parameters per socket tracer if you want specific settings, like disabling the camera trace for a particular weapon. The trace mode, raycast or sweep, affects how traces happen during fast animations. Using raycast can miss hits because of frame rate issues, so sweep mode fills the gaps between traces, ensuring no hits get missed. This system works with different traces shapes too, line, box or spears, depending on your weapon and gameplay. Another key thing is the mesh component tag. The socket tracer needs to know which mesh you track for socket location. You assign a tag to the relevant mesh, skeletal or static, and the tracer picks it up automatically. All these traces and tracers are network replicated, so they work in multiplayer. Now let's move on to the arc tracer. Unlike socket tracers, arc tracers don't follow a mesh but trace in a defined arc pattern, and it has similar settings like hit mode, shape, arc angle and radius. For example, if you want a predictable sword swipe hit detection, an arc tracer does it by tracing along a defined arc over a specified duration. You can set the arc duration to control how fast or slow the trace happens during the animation notify. Sweep mode also works here to fill any gaps. The arc tracer also supports an arc radius modifier, a curve you can add to vary the radius along the arc, making the tracing more dynamic. Both sockets and arc traces have dispatchers that notify when tracing starts, when hits occur, and when tracing ends. For socket tracers, there are 4 main dispatchers: trace started, on hit, on unique hit, and trace ended. On unique hit is especially useful because it fires only one per target during a trace, avoiding multiple hits registrations on the same target in a single attack. Between traces start and end, the system keeps track of all hits to be able to manage this. The combat component itself lets you register and unregister tracers by ID or by reference, clear all tracers, and control starting and stopping traces during animations. If you register two tracers with the same ID, the newer one replaces the older automatically. You can start and stop tracing manually if needed, but the plugin provides animation notifiers that handle this for you. The combat component also has dispatchers for unique hits notifications, and tracers updates, which you can link to affect weapon visibility or gameplay logic. There are helper functions to build and get ignored lists, so the system automatically ignores the player character, inventory items, and child actors during traces, preventing self-hits. Remember to run these functions on the server for multiplayer synchronization. Running them on the client won't have any effect. For more details, you can check the documentation linked in the description. So that's the basic overview of the AGR combat system. It's flexible enough for complex hit detection setups while being simple to use for basic melee systems. I hope this helps you get started with melee combat in Unreal Engine using AGR. And that was it. If you enjoyed the video, please give it a like and subscribe. And if you have any questions, feel free to drop them in the comments below or join our Discord. See you in the next video and keep creating.